Okay, so for trigonometry, let's say you have some triangle, right? So, to start off trigonometry, you have some triangle, and it has to be right angled, okay? So that means 90 degrees, right? 90 degrees right here. So you have this triangle. What's special about it? Well, it turns out that actually if you have this angle here, there are three functions: sine, cosine, and tangent. Now if you take sine of theta, so you would say maybe this is 45 degrees, okay? And let's say you were to say sine of 45, right? And that will give you an output. You can only do this on your calculator. You can't do this on paper or anything. So you would put this on your calculator, sine of 45, okay? And that would give you opposite over hypotenuse. Now, what's opposite and hypotenuse? Well, these are the names of two sides. So sine would be the ratio of opposite and hypotenuse. Let's say cosine of 45. So opposite over hypotenuse. That would get you, now this is the third side, adjacent. It's called adjacent. That would give you adjacent over hypotenuse. Now tangent of 45, let's just say this is just an example number. It can be any other number, right, because the degrees can change. That would get you opposite over adjacent, okay? So these are the three functions that are going to be used. But in grade 11, we go a little bit further. So triangles, like the one we just saw, so right-angled triangles can also be put on a Cartesian plane. So let's draw a Cartesian plane like this. Should be familiar with what a Cartesian plane is. And with this Cartesian plane, we will just draw a line. So it can be a line like this, and it will have a length of 1. A length of 1, right? Right here. And then it can be anywhere. It can go this way, it can go this way, it can go this way. But I just chose to put the line there. So it can be any angle, right? Any angle away from this x-axis, which we're actually going to have a name for it in the next video. But the important thing is, this line always has a length of 1, and you can draw it with any angle away. So it can be this angle, or it could be like this all the way around to here, and then it would look like this. Then would have an angle of more than 270, right? That's theta, right? So we have this line, and now that we have this, we can make a triangle out of it. So just draw a straight line downwards to make a 90-degree angle, so that this and this line and this line are perpendicular. And would you look at that? This becomes your hypotenuse, this becomes your opposite, and this becomes your adjacent, right? So we do it on the Cartesian plane because that way you can look at it as a whole, like you can see the differences of the triangles. Let me give an example. So let's say you have this one, and then you have this triangle right here, and you say maybe it's like 45, and then you were to say, okay, I want to compare this to a triangle that's like this. Maybe it's 100 degrees. I know it doesn't look like 100 degrees, but let's say it's 100 degrees. And then this triangle would look like this, and you draw the line down like this, and you compare it to this one. We also do it for graphing purposes, but you'll see that later. And so yeah, this is 45 degrees. You can see this triangle over here, and we made one. So opposite, adjacent, hypotenuse, and this is always a length of 1. Now, how can we convert it from onto the Cartesian plane to a triangle that's different? Well, so a triangle like this, with a length of 1 as the hypotenuse, right? We don't know what this is or what this is, so we'll just call it opposite and adjacent. This is still hypotenuse, I'm just not writing it. But let's say we wanted to make it bigger, right? Let's say we wanted to make it like 2. We wanted to have it like the hypotenuse to be a length of 2. We could easily convert it to a triangle with length of 2 and lengths of a triangle that has a hypotenuse of 2, and it would just be 2O over here and 2A. You multiply everything by 2. If this doubles, then this doubles. And that way, you can plot different triangles on your Cartesian plane. And then you can also use those triangles and compare them to triangles you might have in the real world, right? So that pretty much concludes the video. Just graphing triangles on Cartesian planes is the new part to grade 11. I'm pretty sure grade 10 has some trig. But yeah, sine, cosine, tangent, all of that. The 3 sides and this angle is pretty important.